chromosomes. They're already duplicated, that happened in interphase. So they're supercoiling, they're visible, they're getting attached to the spindle fibers. The centrioles are going to opposite poles, and the nuclear envelope is disintegrating. Okay, so that's prophase. Lots happening in prophase. Metaphase is really easy, you guys. The chromosomes plus their duplicates all line up on a central axis. Chromosomes plus duplicates line up on the central axis. It's called equator or metaphase plate. There's like 10 different names. Okay. So it looks like this. Really easy to tell. Okay. If you see all the chromosomes lined up on the central axis, it's in metaphase. They don't stay in metaphase very long, but it's the easiest one to tell. So my recommendation to you is find metaphase first, because you know you're going to be looking for chromosomes all lined up on the central axis. Okay, so the chromosomes plus their duplicates all line up on a central axis. That's metaphase. What do you think happens in anaphase? Oh, go ahead. Yeah, they're going to pull apart. So think of prophase before, metaphase middle, anaphase, the chromosomes and the duplicates are moving away, right? Okay, so then metaphase, these guys line up on an equator. So here's your chromosomes, right? Let's just draw those lines. And then the duplicates. Your duplicates. Right? They're all going to line up on an equator. And then in anaphase, they're moving away from one another. So the chromosomes move to one side, the duplicates move to the other. They're going to move to one pole, which would be centriole, right? And then the duplicates are going to move to another pole. Okay. So in essence, these guys are all lined up on a central axis, right? In metaphase. In anaphase, they're going to start to move away. So these guys are going to start to move to this pole, or this centriole, and these guys are going to move to this centriole, right? Because we're trying to pull them to opposite sides so we can split them evenly. Anaphase, think of as away. You don't see. I'll come back to this. You don't see much space between them, but there's space between them. And so anaphase, you're not going to see very many cells in anaphase because they don't last very long in anaphase. They line up on the central axis, they pull apart relatively quickly. Okay, so they kind of gloss through anaphase. But if you find an anaphase, let everybody know so we can kind of anaphase and move away from each other. We can stop the cells in metaphase to look for genetic defects. So if I want to do genetic testing, I can take a swab of my cheek cells and I can halt them and isolate the DNA, and I can line up the DNA or match up the DNA. So this is chromosome 1, the copy, right? Chromosome 2, 3, 4, et cetera, 22. So these are called autosomes because we all have the same genetic information on all of these. The 23rd chromosome is your sex chromosome. So your sex chromosome, if you have an X and an X, that's female, you have an X and a Y, that's male. The egg always donates the X. What dictates the sex? The sperm does. So if the sperm has an X, you're gonna be a female. If the sperm has a Y, you're gonna be a male, okay? There are some genetic issues where you can have another X or multiple X's and a Y. You can have an XXX, you can have an XYY. Not common, but it does happen. And so what dictates a sex? The sperm does. And so I think it's funny that the kings used to kill the queens, so they would have you produce the male heir. It was the male sperm that did produce the male heir. So, but why do we do this? So we can see if there's issues. If we have a third copy of chromosome 21, do you know what that's called?
A mutation or a
It's a
defect?
mutation, but do you know what the specific disease is? It's Down syndrome, yeah, it's trisomy 21, meaning you have 3 copies of chromosome 21. That's gonna give you Down syndrome. Okay, there are other genetic mutations where this part is ripped off and stuck onto this, or you have an extra copy of 14, or sometimes this gets lodged here, or that you get some type of mutation. And so this is what they should look like normally. The genetic people who analyze these guys know what they're supposed to look like genetically, and they match them up. And this is what your chromosomes look like. I think eye color is on 15. I think blood is your blood type is carried on 12. And so each one of these has hundreds of codes or genes that code for whatever you need in your whole body. So this is it. Okay.
What happens when, say like, people have one just kind of random kid that has like completely different traits, like say if the parents have like brown hair, the kid has like red hair, blonde hair, like blue eyes, like how does that happen?
So, okay, let's say, let me try that for you.
Or is it like a mutation?
No, it's not a mutation. Let me see.
You don't have to go like crazy in depth.
No, I'm just trying to think. Okay, so let's say, let's see, okay, so let's go back to chromosome 1, right? Okay, this is from your mom, this is from your dad, right? Let's say you have dark hair and you have a light skin, right? So dark hair and light hair. And this is you, okay? And so let's say you're making eggs, okay? One egg is gonna have this trait in it. So one egg is gonna have this chromosome in it, where it has dark hair, and then another egg is gonna have this chromosome in it, where it's light hair. Okay? Let's say your husband's sperm has, let's say he has the same issues. So one of them, not same issue, but whatever. You guys, I anticipate the next month is gonna be really hard. I'm hoping my brain function comes back, but it's not. So I'm sorry, you kind of have to drudge through this with me. In grad school, we had to discuss research papers a long time ago. But so you're trying to take grad classes, you're trying to do research, you're trying to teach, and you're trying to get through all this literature, right? And so when we would walk into some of the meetings where we were discussing papers, and it would be really painful. Like you just sit there for an hour and know this person did the best they could to read the paper and pull something together, but it was horrendous, right? And so I'm sorry, but this is painful, and it's painful for me to listen to myself, and so I apologize to you guys. Because I'm thinking, listening, like, what the hell are you saying? As I'm saying it. Okay, so let's go back to this. So let's say this sperm fertilizes this egg. What's your hair color?
Dark.
Dark. Let's say this sperm fertilizes this egg. What's your hair color?
Dark.
Dark. Let's say this sperm fertilizes this egg. Dark. Let's say this fertilizes this.
Light.
Light. That's how you get genetic variation. Okay, so my grandfather has dark eyes. my grandmother has light eyes. Most of their kids have dark eyes. My mom has dark eyes, okay? But my dad has light eyes. And so I got the light eye, the one recessive trait that she had, the light eyes, and the light eyes from dad in order to have blue eyes, okay? It's the rare traits. There's also too, when you have these guys getting ready to go, this is meiosis. So when you have these guys getting ready to go through meiosis, you have mixing of traits. And so it gives more genetic variability. So I'm making it easier than it is, really. But that's how you and your siblings aren't exactly similar. Because there's mixing of traits. Okay? And it depends on your parents' genetics, but they inherited it from their parents. And so, because you have grandma and grandpa's genes making up mom's genetics and grandma and grandpa's genes making up dad's genetics, and then they come together, it's different. People look different. Unless they're genetically identical twins, right? If you're going through this and then like the egg fertilizes, you have one, you have a zygote with 46 chromosomes or 23 pairs. And then it goes off and starts dividing into two complete humans that are genetically identical. That can happen. Okay. We're not going to get into that. So, anaphase, they're moving away, right? And then in telophase, they're already done moving. So in telophase, what you see is they're at opposite poles. So the chromosomes are at one pole, right? So we have the chromosomes at this pole, and then we have the duplicates at this pole. Okay, what has to happen though? Is it just gonna sit like that, or are we gonna divide it into two cells? We're gonna divide it into two cells, okay? So these guys have already moved, they're at the end. You're gonna split this into two cells, and the nuclear envelope has to reform, okay? So the nuclear envelope reforms around the chromosomes and the duplicates. You have to split the cytoplasm into two cells, and that's called cytokinesis. This is what it looks like. So if the chromosomes are at one side or at the other side, that's telophase. I'm not going to move much more of this. And then sometimes you can see the cleavage furrow or the line occurring. We call it cleavage furrow. We call it cytokinesis. I consider cytokinesis part of telophase. Cytokinesis is like the end of telophase. Okay, so prophase before, forming before, metaphase, they're lined up on the middle axis. Anaphase, they're moving away. Telophase, they're at the ends. Think of telophase at the end. Cytokinesis is splitting that plasma membrane. Okay. I also go through it this way. So here's chromosome pair 1, right? So chromosome pair 1. One of these is a chromatid. That's from mom. One is a chromatid. That's from dad. Right? So this is chromosome pair 1. How many of these guys do you have in a nucleus? 23 pairs. Okay, or 46. So then this guy goes through interphase. It gets ready to divide. It's going to duplicate. So here's the 23 pairs plus the duplicates. Okay. They're going to line up on a central axis, and then they're going to split into two separate cells. So now we have 23 pairs and the 23 pairs duplicates. They're separate cells. Okay, that's metaphase, or that's mitosis. That's it. Okay. So chromosome 1, duplicate, line up, split. Okay, that's mitosis. Meiosis, you need to go a step further. Okay, because you need one of these in one egg cell, one of these in another egg cell, one of these in another egg cell, and one of these in another egg cell. So that when the egg and sperm join, you now have chromosome 1. So when I go through meiosis, chromosome pair 1, duplicate, line up and split. It's almost identical to mitosis. It's called meiosis 1 though. There's a little bit of crossing over genetic information to get your variability between the siblings, right? So chromosome pair 1, duplicates line up and split. That's meiosis 1. Not done yet though. Now we have to go through meiosis 2. So we have to go through prophase 2, metaphase 2, anaphase 2, and telophase 2. So they're already coiled up, so they're just gonna sit in the middle. They're gonna line up, then they're gonna split. So that you have one of that pair. So you have 23 single chromosomes in one egg, 23 single chromosomes in another egg, 23 single chromosomes and 23 single chromosomes. So how many eggs did I make from one stem cell?
46.
4. How many sperms did I make from one stem cell? 4. Okay. For women, 1 is viable, the rest of them get reabsorbed. For men, 4 are viable. Okay. So then when the sperm fertilizes the egg, then we have our 23 pairs again instead of 23 single chromosomes. Okay. So let's take a look at that. What regulates cell division? Stop signals. So when these guys get too big, when these guys grow too big, when they contact each other, that halts them. They have growth inhibiting factors by repressor genes. Worn out telomeres. This is a really pretty picture. These guys are fluorescently stained. And so here's the chromosome. Here are the end caps. These are the telomeres. The yellow are the telomeres. When these guys go through mitosis, these telomere sections get smaller and smaller. That causes aging. And so that's the aging process. And so when these guys get too small, then they get worn out. Cancer will, you have a mutation that your cell doesn't recognize the stop signals. So you have these genes that turn on mitosis. And so cancer cells are so dangerous because let's say you have a cancer cell in the liver, it's gonna go through mitosis. There's gonna be so many cells, they're gonna push the normal cells out of the way, okay? And then they can go in your blood vessel or your lymph system and get lodged somewhere else and start dividing there too, okay? So that's why cancer cells are so dangerous. Sometimes your immune system will attack the cancer cells and degrade them, so we always have cancer cells being made. But it's when the cancer cells get too active that we have an issue with it. Okay, so cell life cycle, interphase, then mitosis, which is prophase, metaphase, anaphase, and telophase. Cell division or mitosis only consists of peanut. Here's a picture. Can't really see the nucleus in your microscopes because this is higher magnification than yours. You won't be able to see nucleus. So here is the plasma membrane of the cell. Here is the nuclear envelope. Here's the nucleus. Here's another cell. Here's the nucleus. You can't really see the nuclei very well. Take a look when it's in prophase though. Here's the plasma membrane. Here is what was the nuclear envelope. You can see the centrioles, kind of. You can see the spindle fibers. Look at those chromosomes. Those chromosomes are dense. Okay, you can actually see them. And metaphase are all lined up on a single axis. It looks like stitches. Anaphase, they're moving away. This is kind of a bad picture of anaphase, but you'll see a little bit of space in between them. Not as much. This is telophase because it looks like they're at opposite poles. So this is as far as they get. Okay, how do you tell the difference? If you see a little bit of space, it's anaphase. If they're already moved to the centrioles, it's telophase. So that would be telophase. This is telophase inside the campus. So notice how, like telophase, you already have the cytoplasm splitting into two cells. You already have these guys sort of uncoiling to chromatin, and you already have the nuclear envelope starting to reform. It takes a little bit to figure these guys out. How do I memorize them? You just go to Google Images, click on metaphase, just click through the slides. Okay, that's all the way. Let's try some. This guy up here. What face? Can't see the nucleus.
So interface?
Interphase. This one. Can't see the nucleus. Interphase. What are these black dots? These are not nuclei, you guys. These are fat cells, so these are like lipid droplets. When that's a lipid droplet, lipid droplets, lipid droplets, lipid droplets, that lipid droplets. So don't get them mixed up. Embryonic fish have a lot of little fat globules in there for metabolism. Let's see. If you can see the let's see. If you can see the nucleus, here's a good one. So you can see that nucleus. I consider that in prophase. You can see the nucleus, prophase, 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 prophase. Okay. They're all lined up on a central axis. What would that be? Metaphase. I don't see any anaphase. Those are hard to tell. Telophase, I can tell these are telophase because this is at one end. This is at the other end. You can still see the spindle fibers, and cytokinesis is starting to occur. This is probably what your cell will look like. This is like more magnified. So what is this phase? Here's your cell. Here's your chromosomes. Metaphase. What is this? It's hard to tell if it's telophase or anaphase. I consider it telophase because they're on opposite poles. What does this look like? Anaphase or telophase? What do you think? Telophase, they're already at opposite poles. The centrioles are right here. Okay, what does this look like?
Anaphase?
Nope. Opposite poles, and this is splitting in half. Do you see that cytokinesis occurring?
Yeah. So that's the cleavage?
It's a cleavage program, yeah. Okay. So it's gonna be a little bit tricky. Yeah. Meiosis, or sex cells, they go through meiosis one, it's like mitosis, and they go through meiosis two. Here, it results in 23 single chromosomes. We call this haploid or one end. So we're going from 46 chromosomes to 23 single chromosomes, or 23 pairs to 23 single chromosomes. So we're going to 23 single chromosomes. Okay, we call that one end, or haploid. We have to have them get down to that level because we need 23 single chromosomes in the egg and 23 single chromosomes in the sperm. So when they fuse, we have 23 pairs of chromosomes, or what we should have in each cell. Side by side, mitosis, right? You have 23 pairs plus its duplicates, 23 pairs, 23 duplicates. Genetically identical to the parent cell. For meiosis, it's 23 pairs goes to 23 pairs, 23 pairs duplicates down to 23 single chromosomes in each egg. So this is meiosis 1 and then meiosis 2. We don't have a slide of this, so you can use this for your meiosis. So here's your 23 chromosomes plus their duplicates. They all line up on a central axis. They split, right? And so you have 23 pairs here, the duplicates here. And this is meiosis 1. So it's prophase 1, metaphase 1, telophase, or anaphase 1 and telophase 1. And then it's gonna split again. So it's prophase 2, here's your 23 pairs plus your duplicates. And it needs to split into 23 singles, the 23 singles, the duplicate singles, and the duplicate singles. So you have 23 singles, 23 singles, 23 singles, and 23 singles. I don't like this picture because it doesn't show very well. Okay? But you're splitting those sister chromosomes. Okay? And so this is called prophase 2, metaphase 2, anaphase 2.